Welcome back, Focus Learners. Today on The Explainer, we're doing something really fun. We are pulling the cover right off the engine. You know, if you've been building with AI lately, you've probably relied on some of those automation platforms, right? Grabbing a model from a simple no-code dropdown and just letting the platform do all the heavy lifting of managing the API. And hey, that is a fantastic place to start. But if we want to truly unlock the next level of our workflows, we've got to look under the hood. We are moving away from those simple abstractions and talking about direct AI model integration. Yep, we're talking about first-party AI APIs.
Okay, let's dive into this driver's manual for today. We'll kick things off by meeting first-party APIs, then introduce the big four providers out there. After that, we'll break down the actual anatomy of an API call, map out token economics and limits, and finally, we'll wrap up with some absolutely essential API key hygiene. Don't worry, we are breaking this whole complex topic down logically, step by step.
Section 1. Meet first-party APIs. We're totally bypassing the automation platforms to talk directly to the AI labs.
Our source material puts this perfectly, defining a first-party API as a direct credit card-to-vendor relationship for model access. This is just an incredibly powerful concept. By cutting out the middleman entirely, you're essentially giving yourself the absolute fastest path to a working integration. There is no intermediary platform gating in your way or telling you what you can or can't build.
Put simply, a first-party API means you are talking directly to the company that actually made the model. You want Claude? You go straight to Anthropic. You want GPT? You talk to OpenAI. This directness offers a really beautiful simplicity, the absolute cleanest support path, and it gives you access to the latest features literally the second they drop. But we have to be honest about the trade-offs here. You are tying yourself into one specific vendor's API shape, which risks vendor lock-in. Plus, you've got to remember that your data is routing straight through that specific third party's infrastructure on every single call.
Section 2. The Big Four Providers. Let's move to the labs and see how this builds out in the real world.
And this brilliantly illustrates the major characters dominating the landscape right now. We've got Anthropic, the absolute masters of nuanced writing, careful reasoning, and tool use, operating through their native Messages API. Then there's OpenAI, the reigning champions of ecosystem breadth and those budget-friendly mini and nano models. We also have Google's Gemini, which just totally dominates when it comes to massive long context and multimodal tasks with incredibly cheap flash options. And finally, DeepSeek. They are really shaking up the industry with frontier-level reasoning and math capabilities at a super low cost. But here's the clever part. Notice DeepSeek's API style. They use an OpenAI-compatible interface. That means if you've already written code for OpenAI, it ports over to DeepSeek super easily with just a base URL change. Real game changer there.
Now, if you follow the frontier model space closely, you might be wondering, hold on, where is Alibaba's Qwen? Qwen is a phenomenal model family for sure, but it's strategically missing from our big four today. Why? Well, because its direct, first-party API is heavily geared toward the Chinese market. That makes payment and account verification practically unreachable for most global builders. And honestly, this perfectly illustrates why, eventually, you might need alternative access modes, like inference providers. We'll definitely be exploring those in the future.
Section 3. Anatomy of an API call. It's time to fully open up the engine block and look at the universal parts that make an API tick.
Every single first-party API call out there has exactly these 5 parts. First, the endpoint URL, which basically tells your request where to go. Second, authentication, to prove you're actually allowed to make the call. Third, the request body, where you ask for what you want, usually in JSON format. Fourth, the response body, which is the model handing you your answer. And fifth, error handling, for when things inevitably go a little sideways. Knowing this linear 5-step flow is so empowering. It literally means you can read the documentation of any provider on the market, because these underlying parts, they never change.
Speaking of error handling, let's talk about the 2 most common errors you are absolutely going to hit in your first month of building. First up, the 401 unauthorized. Don't panic, this usually just means an invalid or missing API key. Fix your header, and you're good. But the 429 too many requests? That means you've hit a rate limit or a token cap. And the secret here is that 429 errors require very deliberate handling in your code. Do not, and I mean do not, just immediately retry the request. You'll make it worse and get blocked. You need to use something called exponential backoff. That means waiting 1 second, then 2, then 4, to smoothly recover.
Section 4. Token economics and limits. Let's transition to the fuel that runs this whole engine. How models charge you for their compute power.
Now, what's really interesting about this massive jump is the cost multiplier. Across basically all 4 major providers, you're going to find that output tokens cost you roughly 3 to 5 times more than input tokens.
So, why the huge cost asymmetry? Well, just look at the contrast. Input tokens are cheap because they're processed in parallel by the model. Essentially, it's just cheap, fast reading. But output tokens, those are highly expensive because producing them requires a full forward computational pass through the network, token by agonizing token. The model is actively doing heavy computing. Understanding this unlocks a highly economical design pattern, long prompts with short outputs. If you give a cheap model heavy reading work, but rigidly constrain its actual output, you are going to save an absolute fortune.
And speaking of saving a fortune, there are 2 massive discounts that almost always apply across the major labs. First, prompt caching. This can shave up to 90% off your input costs if your workflow uses large, stable system prompts that the provider can just store. Second is the batch API. If you have non-real-time tasks and you're okay waiting 24 hours for your results, providers will literally cut your token costs in half. Just building a simple spreadsheet to model out these costs and discounts before you deploy. It'll save you immense amounts of money at scale.
But when you're managing those costs, you also have to manage your speed limits to avoid those pesky 429 rate limit errors we talked about. TPM, or tokens per minute, is the limit you'll hit for low-frequency but high-token workloads. Think feeding giant documents into a model. On the flip side, RPM, or requests per minute, is the constraint for high-frequency, low-token workloads, like a rapid-fire classification tool. You really need to know which metric your workflow is going to stress.
Section 5. Essential API Key Hygiene. All right, safety manual time. Direct power demands direct responsibility. I need to get pretty serious for a second here. $4,000. That is the terrifying surprise bill a beginner literally woke up to because they accidentally committed an uncapped, raw API key into a public GitHub repository. Automated scrapers found it instantly, and they ran up massive compute bills on that beginner's dime in just a matter of hours. Please, whatever you do not be that builder.
So the crucial point is this. Follow these 5 non-negotiable security rules to prevent catastrophic billing surprises. Number 1, never ever commit keys to source control. Put them in secret managers or environment variables. Number 2, use separate keys for your dev, staging, and prod environments so one tiny leak doesn't take down your whole shebang. Number 3, set hard spending caps on every single key the exact moment you create it. Number 4, rotate your keys quarterly to contain the blast radius if one does quietly leak out. And number 5, monitor your usage dashboards and set spendolence. You have to treat your API key exactly like your credit card because, well, it literally is one.
Which brings us to our final thought for today. Are you defaulting into vendor lock-in, or are you choosing it deliberately? First-party APIs are incredible. They're the absolute fastest, simplest, and most direct way to build, but they aren't the only way, and they honestly aren't perfect for every single scenario, especially if you start needing open-weight models or super strict data privacy. So, challenge yourself. Think strategically about when a direct connection is the right choice and when it might actually be holding you back. Let that question simmer. It leaves you perfectly primed to explore the other access modes we'll be covering in our next explainer. Keep learning, keep building, and we'll see you next time.